In today's session, we will be looking at a way of communication between two processes, and that way and that method is called signals. So signals are available in most of the operating systems in Windows and Linux as well. So in Linux, it is called simply signals, and there are a list of signals, and in in Linux, like there you can see on this web page, you can see that there are some common signals which are like whenever a process sends an interrupt to another process, there is this signal called SIGINT that we will be using today in our lab. And similarly, when a user sends a quit signal to a process, that process will receive a SIGQuit signal. And if the process performs an illegal mathematical operation, uh, there is a signal SIG-FPE generated. And similarly, if a process gets this signal, it must quit immediately and will not perform any cleanup operations. This signal is called SIG-kill. So this is a signal which you can send to a process, and that signal will eventually kill the process without any cleanup operations, which means that it will not look for any the operating system will not perform any address space cleanup or managerial data that it maintains, the records in its data structures. It will not perform any cleanup operations. Similarly, sig alarm is alarm clock signal, which is used for timers. So you can wait for a timer to expire, and whenever that timer will expire, you will get a signal in your process. And similarly, there is software termination signal sent by kill by default, sig termination, sig term. And there are other signals like all of these signals which you can look up, and you can have in Linux, these are all the signals that are received by a process. So let me first explain to you how signals work. So signals are like, for example, you have previously we created a process, right? And we used to send system calls to the operating system kernel. This was the OS, and we used to send a software interrupt to this OS kernel, you can say, using what we called the system calls, right? So we use system calls to achieve this, which were also called uh, software interrupts. Now, what we are trying to do, we are trying to actually um, make, we have a process, we have another process. So one of these processes could either, you know, or there can be, multiple scenarios. Like, for example, there is this user. For example, we have a user, and that user sends a request to the OS, right? This is, let's suppose, the OS, and that request is being sent by the user to this OS. And so we remember that this is the system call, right? So, but now the user is using some kind of IO device to communicate, to send this request to the OS, and the OS, as a result, is sending this request to our process, right? So this is our process. So now we are saying that this request that is being sent by the OS to the process is the signal, right? So this is the signal which is being sent by the OS to the process. Another scenario would be that this is the OS, this is, like, for example, process 1, and this is, for example, process 2. So this can also happen that the process could be requesting something from the OS using a signal or an interrupt, and the OS will be sending another signal to the uh, to our process. So we are right now using this mechanism for as a means for communication between two processes or between a user and a process, right? So signals are normally the common signals are well defined. The behavior as a result of these signals are well defined, but there is a way to modify the behavior of these signals. The most common signal that we see, that we use all the time in our uh, operating systems is, let me show you. So for example, I I use this shell, this terminal window, and I type top, right? So top is a program which doesn't immediately exit when I run it. It keeps on running, it expands as many lines I add to it, it simply expands its view. And this program is continuously updating itself. You can see that the view is continuously updating, and there is no way that I can get out of this program. So if I want to terminate this program, I use Ctrl+C. I press and hold the Control key, and then I press momentarily press the C key. So you can see that now this program is terminated and I am out of this program, right? So this is called uh, terminating the program or sending a kill signal to the program to kill this program, because this program or this process was running continuously. Let me show you once again. So if I run top is the name of the program. It is just like task manager in Windows. So it shows you all the processes that are currently using the CPU percentage and memory percentage and the timestamp and command, the name of the program in file format. So if I want to get out of this program, I use Ctrl+C, right? So this is a common behavior. This is a standard behavior, um, which you see all the time in you know. And let me show you. Let's write some program. Let's call it signal sign.c. Let's suppose, and I'm going to include some files first. Okay, so now for example, if I have written a while loop, for example, it's an infinite while loop like this, right? It will simply keep my program in uh, an infinite loop, right? So now you can see that the cursor is blinking. It is not doing anything because uh, it is right now in infinite loop that I wrote over here, right? So what would happen if I press Ctrl+C? Ctrl+C will send a kill signal to this program, and the default behavior for sending the Ctrl+C signal for a program running in a shell window is to terminate that program, right? So what happens if I want, what would happen and what should be done if I were to you know modify the behavior of this Ctrl+C command? But first of all, let me explain to you the difference between a common keystroke and Ctrl+C. Ctrl+C is similar to Control-Alt-Delete. This is not a commonly used keystroke or key combination that you use in a program. This is something special which does not go directly to the process, just like you are using scanf and the process is accepting keyboard input from the user. This is different as compared to that situation, because it will it is doing something which is not related to a normal operation of your process. This is related to something outside your program. It goes to the operating system and the operating system terminates your program, right? So this needs to be understood first before we go into this, because uh, there may not be other key combinations that you can use to generate signals. So Control+C is that's why used most frequently in these examples. So Control+C is something which is similar to Control-Alt-Delete, which is, or the Windows key maybe, because it takes you from your normal program execution to outside of that program into the operating system, right? So Control+C is similar to that. So in order to modify the behavior of that signal, you first need to type or define a signal handler function, you can name give this signal handler any name you like, because this is a self-defined function, and you can call it any name you like. I'm calling it signal handler. And then you need to, so there's a specific format for that. You need to define the return type as void, and you need to define a, a number type of an integer parameter here, which actually accepts the signal number of the signal that is being raised, for which you have modified the behavior for. So normally we don't use that, so but we need to define the parameter even if we don't use that. So in signal handler we can do whatever we like. For example, I type in printf uh, you know uh, control plus c was pressed, right? I'm simply or maybe I am here because Control C was pressed. Okay, so let's print in this line. And in order to so let's get rid of this infinite loop, and I'm going to use the signal system call to modify the operation of this signal to let's suppose the default name for the signal of this type is SIGINT, and I'm going to mention the name of the signal handler function which I am using over here, right? So this should modify the behavior. And actually let me also keep the while one loop over here, because this line is not going to do anything. The first line is not going to it's not going to be seen as anything happening to the program. It is just registering to the operating system that now whenever the Control C key is pressed, which is called SIGINT in our case, instead of killing the program, do something else, which is printing I am here because Control C was pressed, right? So let's see what happens. Okay, so now I am right now in infinite loop, and whenever I press Control C, instead of my program being terminated, it is simply displaying I am here because Control C was pressed. So now I'm pressing Control C, right? But if I don't press Control C, it does not do anything, right? So the question would now be that how do I get out of this program now? How do I get rid of this? So the answer to that is I cannot. So I will have to close or terminate this terminal window. So let me run another terminal window. So in order to make this program work better, I can again modify whenever I come. For the first time when I come into this, it should do this, and it should also define for SIGINT the default behavior. So I'm going to use sig DFL over here. So now it is an infinite loop, but as soon as I press Control C, it displays I am here because Control C was pressed. First line executed and the second also executed, but it didn't do anything right away. Instead of the fact that it now reset the signal handler to the default behavior of this signal, which would be what?
Program.
Terminating the program. So if I press Control C again, now the program is terminated. So another question you could be asking, why do we call it SIGINT? The answer to that question is that SIGINT is used as an interrupt to the process. It is an interrupt signal, and here you can see that we have used the interrupt signal to send interrupt to the program, and we have modified its behavior as well. So let me demonstrate to you. I just thought of an example. So for example, if I define variable called, let's suppose, state, and the starting value is, let's suppose, 0. And if for the first time it comes in and it checks the state for 0, then it displays, it does two things. First, it simply displays, it doesn't really actually do anything, but it simply displays program paused, right? And but also it changes the state to 1. And similarly, if it comes in with previous state 1, it it simply displays program resumed and changes the state to 0 again, right? Let's comment this out and let's see what happens. And I was trying to make a program that you know displays program resumed once, and the next time when we press Ctrl+c, it displays program paused, once program paused, and the second time program resumed, right? Otherwise it stays in infinite loop. So without any further, try and run this. Now you can see the program is in you know okay. So one thing that we did wrong was here there should be else, and we should get rid of this. Now you can see once I press Ctrl+c, it pauses the program, and then when I press again Ctrl+c, it resumes the program. So this is one example of using the interrupt signal to externally interrupt the normal execution of a program by the user, right? And you can resume the program and pause the program, but however you like that. And I will try to run two processes, and I will try to kill or terminate that program for another process from another process. Okay, so let's there is another way of doing this, is that by, for example, if I define a variable PID, and then if I fork using PID and it save the value in PID, then I can check if it is the child process. Okay, so this would obviously be the child's code. So when I am here, let me simply put the child in while one loop, infinite loop, and if this is the parent's code, then let me, and actually instead of doing this, let me, no, okay, it's while one is okay. So let me give a delay of 2 seconds for the parent process to do anything, and once the 2 seconds are over, let me uh, use the kill system call, which is also the name is kill because the normal operation of this is to terminate a program, but you can also send signals. The basic signal you can, so I can mention the PID of the child process, and then I would be writing the signal that I want to send to this child process, which in this example is again SIGINT, which is an interrupt signal to PID, and that will actually let me modify the example a bit, because I think Ikra or someone asked that uh, are we going to look at other signals, but I want you to understand that only SIGINT is quite powerful. So let me show you how it can be modified, but right now I'm just going to kill the child process using this, and instead of while one, I'm going to write here printf child running, actually simply space like this, and as soon as this happens, what else can we do? Let's so all right, so let's run this before we do anything, right? So for 2 seconds it displayed child running, child running, child running, and after 2 seconds you must understand over here that the parent process killed the child process without the intention of the child to be terminated, right? It is quite obvious from the code of the child process that the child process wanted to run forever. It's a while one loop, it's an infinite loop which would keep on printing child running forever. But because of this command, which was from, and actually, let me print over here that child process will be killed now, right? Let me print that before actually calling the kill system call, right? So 1 second, 2 second, and as soon as this 2 seconds were over, it printed child process will be killed now, and the child process got terminated, right? So the other thing that I was talking about was that let me define a function here called sig handle, and let me whenever it happens, let me just print here someone is trying to kill me, let's suppose. And instead of defining or modifying the behavior of this using this signal handler for SIGINT for both the processes, I'm going to only define the signal handler in the child process only. So I'm going to define here the, before going into the while loop, I'm going to define the signal SIGINT sig handle. This function sig handle will be visible to the parent and the child process both, right? But the signal handler will be modified only for the child process. This is just a regular function. There is nothing fancy about this function, but this function is only being used to modify the behavior of SIGINT for the child process, because I am doing it in the if PID equal to 0 part of this main code. So let's see what happens now. So as soon as I press Ctrl+c, okay, so whenever I press Ctrl+c, both the Ctrl+cs are received by the child and the parent. But for the parent process, I have defined the kill signal to be displaying parent should continue, and for the child process I have defined the kill signal to be someone is trying to kill me, right? So here you can see that whenever Ctrl+c is invoked, it says someone is trying to kill me, the child says this, and the parent says parent should continue.